On April 20th, 2010, an explosion on British Petroleum's Deepwater Horizon oil rig caused the worst oil spill in the history of the petroleum industry. Oil gushed out of the well uninterrupted for 87 days. The total discharge is estimated at 210 million gallons. Our children and our children's children will likely still be cleaning up this mess. Countless animals and plants were killed as a direct result of the oil from the oil spill.
As engineers, we have a responsibility to prevent disasters like this one. What could we, as materials engineers, have done to prevent the BP oil spill? To prevent a disaster, we first need to know how it happened. The initial explosion itself was bad, but not the end of the world. The BP oil spill will live in infamy because it took such a long time to close up the well. Normally, when something goes wrong with an underwater oil well, there is a device called a blowout preventer that can seal the well.
So what is a blowout preventer? James?
A lower marine riser package containing 2 annular preventers and 2 control pods. The lower section of the blowout preventer stack contains 5 sets of rams called the blind shear rams. The casing shear rams, upper variable bore rams, middle variable bore rams, and the lower variable bore rams. The lower marine riser package sits on top of the lower section of the BOP. The blind shear rams are the only device able to cut through the piping.
The blind shear ram failed, which is why it took so long to seal the well. According to the forensic examination of the Deepwater Horizon's blowout preventer conducted by Det Norske Veritas, one of the primary causes of failure was elastic buckling. Elastic buckling is characterized by sudden instability of a structure subject to lateral loads or axial compressive loads. In the case of an axial loaded drill pipe, this instability would result in a lateral displacement of the pipe within the wellbore. This is what a pipe should look like when it's cut by the blind shear ram. As you can see, it is completely cut, and the blind shear rams completely block off the wellbore. This is what Deepwater Horizon's pipe looked like when it was cut. This happened because the pipe was not centered within the wellbore due to the elastic buckling. The blowout preventer failed because the pipe buckled under axial pressure. We need a type of steel that will not bend under pressure, but a stronger metal would probably be more brittle. The blind shear ram works much better with a ductile pipe, modeled by Licorice here, but a ductile pipe is more prone to elastic buckling. Det Norske Veritas determined that the steel in Deepwater Horizon's pipes was a 4340 steel with a tempered martensite phase. Chemically, there's nothing wrong with a pipe. However, perhaps a different heat treatment could have been used on the pipe to get the desired properties. A shorter tempering time would reduce the ductility while maintaining strength. However, this steel would be more brittle. A strong but brittle pipe will not buckle, but will instead shatter in a shear ram, which will prevent the ram from sealing the wellbore. These are problems that materials engineers are working on right now. The major challenge is figuring out how to make this steel cheaply. It all comes back to the triple bottom line. We must protect the planet and the people that reside in it, but we still have to make everything profitable. The BP oil spill is going to be known as the worst oil spill in history. Nothing like it will ever happen ever again. At least if us materials engineers have any say in the matter.